functions are inverses of each other. I want to shoot that in the basketball stud. And you know what I wanted to do in that moment? What did I think?
Ball is life.
I was thinking, how can I get over there and block that shot? How can I leap over these ladies? Okay. And I have to get with my right hand, so you have to swing all that way. So don't do it. Resist. Resist! Here we go. Look at number 3. Aren't y'all glad I'm back?
Yes.
We like how you talk to us on the other video.
Oh, yeah. Did you flinch when I called your name?
Yes.
My name was never said wrong.
Okay, well,
I got one.
I'm sorry. Next time. There will be a next time when I have to review or record my lessons, and y'all, bless you, it's exciting when I have to do that. Here we go. You need to make that happen. What do we do? F of G of N, G of F of N. Whole lot of N's. I guess it better be equal to N, right? Can't be equal to X. It's got to be to N. So what am I going to do? Both of them. They both have to equal N in order for them to be inverses of each other. Compose the functions. You should know how to compose a function. This is a linear and a rational, bless you, okay? Let's take the G function and put it in the F function. So I've got negative 16 plus 4n plus 16, all of that over 4. You with me? If you're not, then you need to write this down. This is the type of composition that I will want you to do. I'm not going to give you ones like number 4. That one, that'd be a good bonus, because what am I really testing? I'm really testing your knowledge on multiplying fractions, okay? But if you can do this problem right here, number 3, you're good to go. Check it out. What do I need to do? What happens to my 16s? They cancel, which is 0, and then I have 4n over 4. Well, what happens now? The 4's cancel, and they turn into 1, and look what I end up with. Hot dang. It's n. That's what I wanted, right? Now let's think. If g of f of n did not equal n, then would the two functions be inverses of one another? No. It would be all for nothing, wouldn't it? That would be annoying. That would be annoying. If I work this first one out, different scenario. If I work the first one out and I get 2n plus 5 as my final composition, my final answer, then do I have to go over here and figure out what g of f of n is? No, why? Because it doesn't equal n, or it doesn't equal x. Do you understand what I'm talking about? Do you understand the words come out of my face? Say that again. What was that one? That was the one we just did, right? I will show you what that looks like here in just a second, okay? Let's check this one. We're hoping that it's going to be equal to n. So let's take the f function, and we're going to put it into the g function. So I'm going to have 4 times negative 16 plus n over 4 plus 16, right? Now, does that bother anybody? Probably bothers a lot of people, because it's a fraction. That usually bothers everybody but me. Folks, what can I write under that 4, this 4 right here? I can throw a 1 under there. Now you can do one of two things. I can distribute the 4 to the numerator, each element in the numerator, and then I can go back in, reduce, or I can do my reducing now. How can I reduce this now, right now?
Divide everything by 4.
Cross out the 4's. I don't want to touch this 16 because it's really not involved in any of this mess, right? If you're on the outside of mess, stay on the outside of mess, y'all. That's a life lesson. Just saying. But can't I do this? 4 goes into 4 one time. 4 goes into 4 one time. Can't you do that? Yeah. And then look, I've got 1 times that quantity over 1. Do I have to write it over 1? No. Don't forget about this 16 right here. Bring it down. Now look what's going to happen. What you tell me. 16 cancels and I'm left with, are they inverses of each other? Yes, they are. And that's all you would put. You would put F and G are inverses of one another. You have to show the work, and then that is your final answer. You have to write it out, that yes, indeed. Because think about, if I were to hand this to any other math teacher, okay, they should be able to know what you're doing without a lot of brain power. They shouldn't have, the wheels should not have to turn if they look at this and go, oh, look, they composed both. Oh, I know. Oh, yeah, I remember. They shouldn't have to do that. They don't look at your work and go, oh, they're inverses of each other. Oh, yeah, I remember that. Okay, because that's your work, okay? So let's look at number 5. We've got to see if they're inverses of each other, so we've got to go f of g of n, g of f of n, right? And they both better equal to what? They both better equal to n. So that's what I'm looking for. This is what we want, right? Can I get an uh-huh? Okay. All right, now watch this. Here we go, here we go, here we go. Check it out. F of g of n. That means I have to plug what in where? G into F. So I'm going to plug negative 3 plus n cubed, whoops, plus 1 quantity cubed, right? You see what I did? Everybody good? Yeah? All right, got to do some simplifying. 3 and 1 is 4. I'm going to go ahead and write that as n cubed plus 4. You with me? Folks, this is going to be like some algebra on steroids and an energy drink, and they just ate Pop Rocks and Fun Dips all at the same time. Okay? Like serious sugar, ooh, hyperness. Here we go. I'm going to write this quantity how many times? 3 times. Why? Because it's to the 3rd power. Okay? Watch. This is so much fun, Kaylee. It's going to be a blast. Here we go. I'm going to FOIL the first 2 binomials. First, outer, inner, last. Check this out. Folks, it is 7:50 on the video. You may want to just sit and watch this happen and then go back and copy it later on your own time. But it's 7:50 if you want to stop and just put your pencil down and watch. N cubed times n cubed is n to the 6th, isn't it? N cubed times 4 is 4n cubed. 4 times n cubed, 4n cubed. 4 times 4 is 16. Now we've got to go back and we've got to combine 4n cubed plus 4n cubed, which is 8n cubed plus 16. Now I'm going to just tell you, I'm going to be annoyed if this doesn't work out, because I will have done this problem for nothing, and it will get on your nerves.
Can you go back up?
Mm-hmm.
Where'd you get like the N6? Why am I going to do 9 and 9?
Because when you multiply variables, you have to add their exponents. Okay? Good question. Now, what do I have to do? Now I've got a trinomial times a binomial. I have to distribute. Now, let me just ask you, some of you do not like having the binomial at the back. So is it legal for you to move the binomial to the front and distribute from the front? Yeah, it is. Do you know why? Do you know what property says you can move things around and it won't matter? The commutative property of multiplication says I can move things around because 3 times 2 is what? 2 times 3 is, order doesn't matter, right? Associative property, that's when the grouping changes. I don't want to change the grouping. So here we go. I'm going to distribute backwards. That negative sign has to stay out here by itself. N to the 6 times n to the third is what, everybody? N to the 9. 8 n to the 6th, 16 n cubed. 4 n to the 6th. Please don't let me make a careless mistake. Everybody see what I just did? And now I've got to combine like terms. So R node n to the 9th, 8 n to the 6th, 4 n to the 6th, n to the 3rd, n to the 3rd. N to the 9th. That would be 12 n to the 6th, 48 n to the 3rd, plus 64. Y'all with me, yes or no? Am I going to be annoyed when I finish this next line? Why? Because it does not equal n. Dag nabbit. Isn't that? Oh, that gets on my nerves. Is that even cool? No, it is not. Finish this up. If I get to this point and I'm like, it doesn't equal n. How do I tie this up? You just write F and G are not inverses of each other. You know, if you needed to put as a side note y, then you could do this. Because they're supposed to both be equal. Once I compose both of them, they're supposed to be both equal to n. Okay? But that's what you would do. And that is the crazy, crazy algebra behind it. Number 10. But it's a good review for us. So when I'm just determining the inverse of the function, what do I do? This is actually this equation, right? Now what do I do? Yeah, see, this part's the easy part. Y'all get this. I gotta get y by itself. What do I do? Add 2. Now what? What am I trying to get by itself? I'm trying to get y by itself. Can I show you something? Okay. What do I really need to multiply to both sides of this? The y. Whatever's in the denominators. Whatever you want to move out of the denominator is what you need to multiply by. However, I look at this problem through a different set of glasses. Because I see an expression equal to a fraction. Something equal to a fraction. What do you think I'm going to do? I'm going to put that expression over 1, and then I'm going to cross multiply. Because to me, that's so much easier than trying to figure out what do I multiply by. And then you multiply by the wrong thing. Okay? Check this out. Watch what's going to happen. Y times that quantity, leave it. Don't literally combine them yet. 1 times 1 is 1. What am I solving for? So look at what we have. What do I have to do? No, I don't. I want to get y by itself. So I don't want to multiply or divide by y. I want to divide by that expression, x plus 2. That way it's going to set y by itself. That's out. Look how easy that is. Just for kicks and giggles. What can x not be equal to? How come?
Negative.
Because it said it equal to 0. But if x is -2, what's going to happen? And that means it would be undefined. Just for kicks and giggles, I had to ask that. You don't have to do that when writing the inverse, but I just needed to know. That's the inverse, folks. That's the inverse. Questions?
Are you going to count off if we don't put the little f part of x?
We gotta do that.
Could you have distributed the y instead of,
I could have, but you're causing yourself a little extra work.
because I got a different answer.
Did you get this? Okay. How are you going to get y by itself? but you can't divide by x if it's not in this one. It would have to be in both of them, okay? If we did this, then you're just gonna have to back yourself back out, factor out the GCF, and we're back to what I had right here, okay? You have to keep the y by itself, not yx, not 2y, the y by itself, okay? All right, let's look at 11. Two x cubed plus 3. What's first step? Come on, come on, come on, come on. Switch x and y. Okay, you don't want to miss this. Look up here. Here, come over, come here, come here. What am I going to do? Subtract 3. Now what? What we do to one side, we have to do the other. Oh, look, I'm done. Yes! Why do I have to cube root it? Because it's a cube. And I'm not looking for y cubed, I'm looking for plain old y. So cube root, what I did to one side, have to do the other. Is that okay? Yes, all right.
Would you put plus or minus, or would you just leave them cube?
No, I leave it like that. I leave it just like that. Hey, I could write it. Ooh. Wrong.
1/3.
Add a 4. Couldn't I write it as a power of 1/3? That will help you in calculus. Oh man. Ooh. Okay. That will help everybody. Pardon? Yeah, but baby, I'm leading you right through that valley.
What's on the other side of calculus?
College.
Are we gonna like cry the last day?
Yes, you will cry. You will. It will be either crying because I love her so much, she's the best, or it will be like, I'm so glad this class is over. Yeah. And it'll be tears of joy, and there will be bittersweet tears. In calculus, Jordan did one day, but he did. But don't tell. Don't tell. Don't make fun of him. It's just, we're sensitive. It's okay. Not here to cry. No, not yet. Has anybody? But it gives you good practice. Subtract 1 right on. Look here, look here, look here. What do I do now? Divide by -4. Seriously? I mean, that right there is a technical foul. Free throw. It ain't nobody down there. If you miss that shot, you ought to have to run laps until you puke. Parker, seriously. Seriously. Yeah, negative can be anywhere. If it were in both places, though, what would happen? Then it would turn it to a positive. It can be either at the top or smack dab in the middle, right in front of the fraction bar, or at the bottom. It just can't be both places. Okay? Questions? You are not going to see one that easy. That is like algebra 1. I will not. I refuse. Not going to do it. Denise, I'm not going to. You know that it's a parabola. You know that because it is a squared term. What does this right here determine? Up or down? Is that going to go up 1 or down 1? Up 1. This thing right here, plus 2, that's inside the parentheses, what does it determine? Left and right. And if it's plus 2, it's going to go right. 2, right? No, woman. It's going the opposite, right? Correct? So it's going to go left 2. I need you to, here we go, check this one out. I'll make you stand up and do this. What function is that, Kaylin? What is it? What do I call it? John Travolta. I like it, John Travolta. Where does it go? Where does it go, Parker? Does it go up, down, left, right? How many? How do you know? Does it say it's -1, woman? You're right. Down 1, right? Correct? How about this? How about this one? Watch it. Watch this. Watch. Hold on. Hold on. Watch. Yep, you got this? Can't really think fast.
Ask for the inverse of the other one.
No. If functions are inverses of each other, though, they are symmetrical about what line? Y equals X. What function is that called?
Identity.
The identity. Folks, that is straight out of your notes. If two functions are inverses of each other, and we plotted points and we graphed them, they would both be symmetrical about this line right here. Remember that? Inverses. Golly, inverses are so easy. I just don't even feel the need to really continue with this.
Do you like graph it?
Yep, that's exactly what you do. Why?
Because like,
Why do you switch the points in inverses?
it's the inverse.
Because it's the inverse. That's what you do on the inverses. You take your X values and you now make them what? The Y values. That's right, class. Calm down. You're talking too much. Jessica, shut your face. Here we go. Haley, I see you back there whispering. Shh. 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 That's 4. Here, don't. Look, if this is the way y'all want to play this, let's fill in the blanks. A polynomial function is the sum or difference of many terms, or monomials. What's that mean? Mono means one, okay? One term things. A polynomial function is a continuous function. No holes, no gaps, no asymptotes. What's the only function that has an asymptote? Rational functions, okay? They are smooth and rounded terms. What they look like. And we've really already talked about this, but the leading coefficient determines the end behavior of the function on the left and right ends, and of course, of the right and left of the function of the curve itself, okay? Now, if the leading coefficient is positive, then it's going to be turned upward or downward? It's going to be turned up, upward.
Does that look from the piece?
Yeah. And then, of course, if it has a negative leading coefficient, it will be turned downward. Folks, this is pretty cut and dry, okay? If it is a positive parabola, then it's going to look something like that, isn't it? Is that smooth and rounded curves? Yes? Okay. Is it a continuous function? How do you know? The arrows, and there are no holes, no asymptotes, no gaps, right? What about this one? What's another one?
Q.
How about that? Is that turned upward?
6.
How do you know? What, 6. What do you mean 6? 1, 2, 3, 4, 5, 6. So if this right here, Winston, is an x squared function, then you're saying that this one is going to be what? You think it's going to be x is equal to y is equal to x to the 6th? Do you guys agree with that? You're right. Okay, very good. Now what about the cubic? The cubic function has one arm up, one arm down, doesn't it? But now that's the thing. Is it going to be like this, or is it going to be like that? Which one's it going to be? The one on the left or the one on the right? Why? No.
That is false.
How do you mean it's positive? I've talked about this before, I think.
It just looks positive.
Just, what do you mean describe it? Oh, if I were to draw a dotted line, it would have a positive trending slope, wouldn't it? So this is a positive cubic function, x cubed. This one over, whoops. This one over here is going to be y is equal to negative x cubed, won't it? You need to draw that because it's going to have a downward trending slope. Does that make sense? That's the only way I ever figured it out because I could never figure out which arm needs to be up, which arm needs to be down. And then, what's your negative leading coefficient functions? And use them, compare them with what we already have. Draw them for a parabola. Draw them for a 6th degree polynomial. And see what you get. Who knows how to draw the negative leading coefficient parabola? Who's got it? Come on, come on. KG, I want you to put it on the board. Who's got the negative 6th degree polynomial? Who's got it? Come on, come on, come on, come on, come on. Somebody step out of the comfort zone.
Okay.
Go ahead, Heather. Is Kiana correct on this one? Yes, no, or maybe?
Yeah.
Yes. Is her equation correct? Yes. All right, Heather, what's the negative leading coefficient for the 6th degree? Yeah. Is that picture correct, y'all? Yes or no?
Yes.
Yep. Is her equation correct? Yes. So you get the point. Folks, this will be most helpful to you in calculus when you're able to go through these quickly and say, oh, that's a W, oh, that's an M. Look, it's a cubic with that upward trend. You'll just quickly, these are like tools that I'm giving you because when you're using a calculator, no way, you've got to know what it's supposed to look like, okay? Any questions, comments, or remarks? All right, good. Here we go. Check this out. The degree of a function is determined by the highest or largest exponent of x.
Get out of your way.
I want you to copy everything down.
I want to raise a ball.
Rights and wrath? Definitely. But not old.
We love the
Hey,
jungle.
I like the jungle. I just don't like the way it ends.
I've never read that. Hey, guess what though? You know what I do know? Degree of a function. Let me tell you the way it is. I'm about to tell you. I'm gonna spoil it. Spoiler alert! Also determines, the degree of the function determines the total number of, use your context clues. Thank you, context clues. The degree of the function determines the total number of zeros or x-intercepts the function has. It does not necessarily mean it's the number of real number zeros. For example, we know that x-intercepts have to cross the x-axis, right? But if you do what Winston did a while ago, then the degree of this function would be, now what did you do earlier? You counted the valleys and the mountain tops, right? You went 1, 2, 3, 4, 5, 6, correct? So folks, the degree of this function would be 6. However, how many real number x-intercepts are there? There are only 4 of them. What does that make the other 2? Imaginary. Isn't this a review from Algebra 2? Okay, that's what we're doing. How are you going to write a degree 0 function?
The identity function.
No. Because degree 1, if this is degree 6, what would this equation look like? Y equals something x to the what power? And it would be x to the 6th, right? So let's back it up. What would degree 3 equation look like? Y equals x to the 3rd. What does a degree 2 function look like? You see the pattern? What's the degree 1 look like? Now, what's that function? That's the identity. What's this one's a degree 0?
Doesn't.
This is your constant function. Now let me tell you why. Excuse me, this is going to be y equals any number. If you remember, side note, we went x to the 3rd, x squared, bless you, x to the 1st, x to the 0, right? What is 0? Anything raised to the 0 power. It would actually be what number? 1, isn't it? Anything raised to the 0 power is 1. Correct or incorrect? Get your calculators. You don't have to. I got mine. Watch this. Watch this right here. You don't have to get them out. Nine raised to the 0 power. 1. Okay? Oh, here it is. X raised to the 0 power. 1. That number raised to the 0 power is 1. How to the 0 power is what? 1. So, 0 degree function is a constant function, which is going to be y equals any number. Okay? So your constant function is going to be a horizontal line, isn't it? Yeah. Your identity, your degree 1 functions, won't they be? And of course, I'm using all what kind of leading coefficients? Positives. I'm using positives right now. The degree 2, it's going to be that parabola turned upward. And the degree 3 will be the John Travolta with a positive trending slope. Yes, no, or maybe? Okay. You remember this, right? Okay. Let's look at the next piece. Any questions at all? Check this out. Even or odd?
Can I have a brain break today?
Yeah, hold up. You getting ready to get one. Hold on before you start writing all this. Look what I want you to do. This is all I want you to write. Even versus odd degree. Even degree functions are going to be either 2 arms up or what? Or 2 arms down. Your even degree functions are going to be 2 arms up, 2 arms down. Or all arms up, all arms down, because if it's a 6th degree, the arms are going to be up. So maybe we just need to say arms up, all arms up, all arms down. It has to be either or. It can't be both. The odd degree functions, you tell me. 1 arm up, 1 arm down. 1 down, 1 up. There's nothing, come on now. You know the difference between evens and odds.
Can you determine if it's like positive or negative?
Yeah. By looking at the leading coefficient. That's all. I'm going to zoom through this section, this unit in chapter 2, because we've got to get to the trig. The trig is where it's at. You've got to understand the trig. It will benefit you in calculus. Now, That's pretty simple, right? We made that easy. Let's move on. The sign of the leading coefficient tells us, what's it tell us? The sign of the leading coefficient,
Did you repeat it? Like up or down?
be more up or down, tells us up, upward, or downward. I mean, we've said that already today, probably 3 times. Yeah, you may not have it today. Because I'm bound and determined we're going to get through this. So let's look at some odd degree functions, okay? Positive leading coefficient, odd degree function. You know, we look at the graphs from the left to the right, correct? Everybody with me? Okay, you with me? Yeah? Okay. Where would an odd degree function start? Which quadrant? If it had a positive leading coefficient. It would start in the third. Why? Because it better end up where? It better end up in the first. Is that positive leading coefficient? Okay. It's going to start in the third, and it's going to end in the first. And then look at what this says at the bottom. It's already in limit notation for you. The limit of the function as x approaches negative infinity is going to be equal to what? What are the signs in the third quadrant, y'all?
Negative.
Negative, negative. So what am I going to put here in the blank? Negative infinity. I could do the same thing for the quadrant 1. You do that now. All right, so quadrant 1, the signs are what? Positive, positive. So that means the limit of the function as x approaches, you tell me, positive infinity is equal to positive infinity. That's better, isn't it? Yeah? How many of you got that? You got it. This is so easy. Bring this test on. Okay? How about the negative leading coefficient? Where's it going to start? Quadrant 2. Hey, can it look like this? If it starts in quadrant 2, it better end where? It better end in 4. Could it do that? Yeah. What would the degree of that function be? How do you know? Well, it has to be odd. How do you know it's 5? Count them. Count. 1, 2, 3, 4, 5. Do you see it? So this is going to be a 5th degree polynomial that's going to start in the 2nd quadrant and it's going to end in the 4th. Do we need to write limit notation? Seriously. Do we need to write limit notation? No. You should know how to do that. Okay? What do you think is going to be next? What do you think is going to be on the next slide? Okay. Does everybody have this? You need another minute. You know the next slide's going to say even. There you go. Do that one yourself and then turn next to, or to the person. Any questions on these at all? Notice where they start. Q2 and they end in Q1, right? And then the negative Q3, Q4. Right on? Doesn't matter how many doesn't matter how many there are. All right, so here's what you're going to do for me. 4, not that. 4 homework. Tomorrow, you're going to do a lot of good stuff. A lot of good stuff. I want you to look at page 105.
This makes fun.
Oh, it's so much fun. I'm going to give you this, and then we're going to do a little something fun. And see how smart y'all are. I want you to look at 64 through 67. I just changed my mind.
No.
I know. I hate when she does that. What?
Here we go.
Oh, y'all really gonna do that?
This is so much fun.
Isn't it? Yeah, do that for me. Right there.
Wait, you kept it? I didn't.
Yeah, I kept it. I know. Okay, now look, the instructions. Here are your instructions. I want you to tell me the degree of the polynomial. I know. I then want you to tell me, is it even or odd? And tell me, do you have a positive or negative leading coefficient? I mean, seriously, that might take you 5 minutes. You're welcome. Okay?
What's the fun thing?
The fun thing. Okay, you ready?